So here's some flexible OLED. So who are you?
So my name's Tom Taylor. I work for CPI, the Centre for Process Innovation. We're a technology...
Is that in the UK?
That's in the UK, in the north of the UK. We're a technology and innovation centre. So this is a flexible OLED. You can bend it. It's printed on plastic, and we have coated the plastic with a membrane barrier that keeps moisture from damaging the electronics. Normal plastic and the device would fail very quickly, whereas this device lasts for several months in operation.
So that's OLED, that's flexible and with plastics. And
Yep.
what are we looking at behind there? Is which part is what?
That's the electrode that's deposited on the back, the aluminium electrode, and then you've got a transparent electrode on the front, and the light emitting material that's glowing green.
And did you tint it for green, or how does it work? How do you choose colors?
So you can do any colour you like. This green colour is is popular with us because this is printed for a medical device, which I've got here. This is a device that glows green, which patients wear at night, and it reverses the effects of two eye diseases that cause blindness. One is age-related macular degeneration, and the other is diabetic retinopathy, which is a disease that all diabetics suffer from. It causes blindness in old age.
So actually, this is a medical use of flexible OLED.
That's right.
So where would the patient use this?
So typically, the patients go blind because they suffer from poor blood circulation. And at night, the eye, unlike most organs in the body, the eye is highly active at night. The rods, without much light, are having to strain at full power to see any light. Part of the eye, the cones, go to sleep at night, but the rods are wide awake and they use up more energy than the eye can supply. So with old people and diabetics, the rods become leaky and protein gets deposited on the eyeball, causing the patient to go steadily blind. Standard treatment is laser ablation or an injection in the eyeball, but eventually the patient loses their eyesight. This treatment puts a very dim glow into the eye. This shows it being squashed.
So it can be squashed.
So we've squashed it over 5,000 times.
All right.
That's to demonstrate it truly is flexible.
What kind of other uses are there for flexible OLED?
So the Internet of Things, you can print outputs. So you could tell, so one of them is card games, board games. The output on, say, packaging, you can tell how much product there's left inside.
Could it be on clothing?
Could be on clothing, yep, because it's flexible, stretchable.
Nice. What are you showing over here? So what kind of other things does CPI do?
So
CPI is a
Technology and Innovation Centre. This biologics facility is where we've developed scale-up technology for DNA-based medicines. Modern medicines can be personalised to treat cancer and other diseases.
Personalised by DNA?
By DNA, by the individual's DNA.
So you take the DNA of the person and then you can give them unique medicine just for that person?
Just for that
person.
Does it
work?
And it works.
Or is it just research?
7 of the top 10 drugs are made this way, based on proteins that are very specific. So they're non-toxic, unlike small molecule drugs.
So they're given to each patient individually based on their DNA?
That's the idea, yes.
And this is already in mass production?
So some of these medicines are in mass production, but it's the future. So what we do is develop the diagnostics to measure the DNA, but also you need cheaper ways of manufacturing it, because making the medicines by today's technology in steel vessels is very expensive. So some of these anti-cancer treatments cost $100,000. So what we're developing is the ways to mass manufacture individual medicines. So the machine is by the bedside in the hospital, and it makes the medicine individually.
How soon are you ready with that? How soon is it work?
Well, we're working with the biggest drug companies like AstraZeneca, GSK.
to get it out as soon as
to
possible.
get it out in the next 5 years.
All right. What are we looking at here?
So here is the Internet of Things. So this is a company, a spin out from London University, who developed a glucose sensor for measuring blood glucose. But the patient breathes on the sensor, so instead of pricking their thumb to get a glucose measure,
Really?
they can breathe on it. What
Really?
we've done is develop a scale-up method for printing the circuits for them.
So this you just breathe on it, and it tells you how you are with the diabetes stuff.
Yeah. So, because diabetics have to measure their glucose level several times a day to check that their insulin pump is working set correctly, which means a finger prick, whereas this is just a simple...
Finger prick is not very nice if you have to do it several times
Yep.
a day. Even one time is not nice.
Yeah, that's right.
And there you just breathe into your smartwatch,
Yeah.
and then it will tell you how it is. And how far is that?
This is probably a year or so away from...
Just a year. And you would have a sensor like this on your smartwatch or on your something.
Yeah. Yeah, I can't quite say exactly how they're going to...
But how is it going to be reliable compared to a prick and compared with blood?
Well, that was their university innovation, was to get the sensor reliable enough to be in use. Where we come in, we are not the inventors. We come in to help people
Make it mass production.
mass produce it. That's our
That's
role.
awesome.
Scale.
That's the most important part of Edward technology, right?
It's the area where the UK lags behind, and that's what catapult centres like mine do, is help companies translate these ideas to commercial
So
reality.
the UK is lagging behind compared to the US or what?
Compared to most developed countries, Germany, Korea, the US, we're very good at inventing, we've got very good universities.
But then you get
But
out
we
of the
miss
UK
out.
to make it real.
Yeah, people have to go somewhere else.
And that's very important.
We're trying to reverse that. We're trying to get more of it made real in the UK.
And what are we looking at here?
So here are printed antennae for the Internet of Things, and these are silver inks, but we've got a series of carbon and graphene inks
All right.
to try and take metal out of the systems to make them easier to recycle. So
Take the metal out of. So this is not metal?
this one is metal,
Yeah?
but we've somewhere here I've got a carbon one. I've got carbon ones where
Carbon.
you're taking the metal out, and they're related to these. This here, there's a company in the UK called Pragmatic Printing. They've developed an all-printed chip. So this is a non-silicon chip. It's a plastic electronics chip that they can print by the million. And the idea here is to get intelligence onto packaging. So with this antenna and this chip, you can put the power from your phone using near-field technologies. You can interrogate the chip and put information into the device and then take it out. Ask the device how full it is or the state, the quality of the product, and it will transmit that
Is
back
it a
to you.
printed chip?
So it's a printed chip.
But how does it compare with an ARM processor? What can it do? It's like very basic.
So the company that's invested in Pragmatic Printing, one of the companies, venture funds, is supported by ARM.
This is why ARM showed it at the ARM TechCon. It showed a flexible ARM processor of the future.
Yeah,
So they're probably working there.
it could well be. I don't know
Yeah.
what that specific example, but it could well be this technology. To give you an idea, Intel make 100 million microprocessors a year, and they
can
sell
make
for
one-
about $100
You can make 100 million a day.
a year. Intel make about 100 million a year.
Yep.
ARM make closer to $1 trillion a year, and they retail for about $10, and they're in every mobile phone. Pragmatic's model is to make trillions for less than a penny, less than a cent.
Right. Well, ARM, I think they're saying 12 billion or something, right?
Yeah.
So, but this could be trillions of chips for even much cheaper, and it could be even ARM processors.
Yes.
It could be anything.
Well, at the moment, they're fairly
But-
simple
yeah.
circuits.
And are they just prototyping, or are they real? Are they being used somewhere?
So they're at the prototype, and so they can make these in the thousands. We are working with them to develop the technology so that they can make them in the millions to take it to market.
So you're helping those guys to bring it to real
Yes,
life.
to scale it up.
How far is it?
but they can make. At the moment, they can do their pilot processing in our fab, and they're now investing in the technology to take it to the next stage of development.
So maybe next year? Or no, longer.
It's hard for me.
Takes,
to be
it depends.
precise.
What's this? This one?
This is printed copper. So this is roll-to-roll printing of copper circuitry, developed by Cambridge Inkjet Technology. This is so companies can send a circuit design to CPI, and we print by inkjet printing a seed layer, and then we develop that electrolytically to produce circuits roll to roll, and we will then post back the circuit to the company or further process it. So this near field communication chip, the copper antenna was done using this inkjet printing technique.
Right.
But it can be done roll to roll.
Cool. Why do you have a face right here?
That's, I think I've mentioned that. That's the
That's the one.
that's the mask for the
That's awesome. So really looking forward to all these awesome things coming to market.
Yep. You'll see
And,
these in the next 5 years.
So
That's
you're
the
busy.
idea.
You're staying busy.
We're very busy. Yes, our fab is full.
It's great. And expanding?
Yes, we've just opened a graphene lab to bring in graphene inks, and that's looking at taking metal out of packaging and antennas. It's looking to make materials stronger, but also conductive to take weight out of products. So that's the next development. But the big thing coming along the line for us is the Internet of Things.
Cool. It's going to
Okay.
keep you busy. Cool. Great.
Could you send me a link when you